So I'm involved in a couple of projects with collaborators. I'm a sweet corn breeder, and we're doing some sweet corn work as well, which I'll tell you about. But I'm involved with a couple of collaborators from Iowa State University, Thomas Luberstadt and Paul Scott, our geneticist, and Kathleen Dellett, who's a agronomist, and some of you probably have interacted with her over time. And what we're doing is developing systems so that it's easier and quicker to breed field corn, especially, but we're also working on sweet corn, under organic conditions. Because obviously, the field corn conventional crop is way ahead. As I just told you, just using the inbreds that they've already developed, which is what's going on now, does not help you in terms of seed cost. So we need to have rapid methods to develop new varieties. The other thing that relates strongly to that is that essentially all major field corn breeding companies now use a technology called double haploids, which essentially are instant inbreds. And that, I'm not going to go deeply into the technology, but what happens is they can go from a open pollinated breeding population to inbreds in basically a year, 2.5 seasons, one season here, one season in South America, and then the next season they could have new inbreds, whereas the conventional way takes 5 or 6 years. And so all the companies have gone to this. The methods that are used for that are not organic compliant. And the main reason is that there's a chemical. So basically what they do is they identify a plant that actually has half the normal number of chromosomes. And that's what they want. But then they need to double the number of chromosomes, and that's called double haploid, and that's the new inbred. They use a chemical. It's a pretty noxious chemical. It's a very noxious chemical to double the number of chromosomes. It's carcinogen and a mutagen, and I've seen in Chile, I've seen the waste, it's called colchicine, the waste colchicine sitting in vats the size of that table. And I don't know what they do with the stuff once it goes into vats, but so it's basically non-compliant. So Thomas Luberstadt out of state has developed a spontaneous double haploid system, and that means we don't need to use colchicine. So we can get to that point of new haploids just as quickly as the traditional method, but without and being organic compliant. So that's really the big thing that we're working on. And we're incorporating that gene into field corn, we're incorporating it into sweet corn, and we're going to be breeding those lines under organic conditions. And I think once we move this technology into the market, some of the companies that retail organic seed will actually be interested in developing varieties using that technology. The other technology that's a bit of an older technology, but we do have a grant as part of this grant with Luberstadt to incorporate what's called gametophilic incompatibility. And what it is if your line or your hybrid has this incompatibility, it blocks foreign pollen. So if your neighbor is growing GMO and you are growing an organic crop with gametophilic incompatibility, the amount of contamination will be greatly reduced. I never like to say 100% because in biology nothing is 100%. But it's going to be very, very greatly reduced. So that's another part of this work we're doing. I do also want to mention that, as I said, I'm mainly a sweet corn breeder, and I am developing a number of sweet corn hybrids. Well, these are called open pollinated populations under organic conditions. And as I said, with the traditionally bred field corn inbreds, we are breeding material that is competitive with weeds, both in seed production but also on your farm. And so we're breeding for vigor, seedling vigor, improved cold soil germination. These, I will admit, are not the high super quality sweet corns that need to be transplanted, but we want to have some very good quality material that can be direct seeded, and we're working on that. We're also working on disease resistance, which again, a lot of the conventional, not the conventional sweet corn breeders, they actually know they have to deal with it, but a lot of the conventional field corn breeders now have gone away from it because they're owned by companies that sell fungicides. So we're concentrating on disease resistance, and we're also concentrating on insect resistance, which is the hardest one, and that's mainly for the corn earworm in sweet corn. And we may have made some progress. I won't say that we definitely have or not. So those are the 4 projects that I wanted to talk to you about today. Breeding for disease and insect resistance, breeding for improved germination and improved vigor, and then, as I said, the double haploids, spontaneous double haploids, and then the immunophytic incompatibility. Happy to take any questions, and yeah.
You mentioned the things you were looking for. Have you guys done any work with specifically river riding, like fun riding, sealing, things like that? Better worse change?
The question is, have we done any work on any kind of basically microbiome, but specifically mycorrhizae in our work? We have not. I mean, I have not correctly done some of the work in the past. I'm not doing it now. But we are growing under certified organic conditions. So that's part of we hope, the package that we're getting as we grow under those conditions. Margaret.
So can you explain the spontaneous combustion? Spontaneous.
I can more easily explain spontaneous combustion if you want.
Well, and the follow-up is, how soon would that technology be available?
Corn is a highly genetically variable organism, as you probably all know. And Thomas just happened on a line that does this, that has the genetics that do that, through the spontaneous stuff. So we need to incorporate that in current field corn. In my case, in current sweet corn. That's what we're doing.
So I'm trying to get my mind around this. When does this happen?
Well, it has to, in this case, it has to happen after you have the haploid.
Right.
So in that case, when you have selected these lines that only have half the number of chromosomes, a fraction of those will actually automatically double. And you might be thinking of the big question: are they going to double again when they're diploid or have 2 sets? And there's no evidence that they do that. So, and it's going to take time. But we'll be actually trying to do this probably in the next. To do this by this, I mean the whole system with sweet corn and field corn in the next 2 years, 2 or 3 years. But then we're going to actually have to select among all of those new inbreds and find the ones that are best. Yes, again.
I'm just curious if the terminology with the spontaneous technology. Is this something you said you happen to find this on a high variability? Now, is this something you just kind of have, like it's intellectual property? Is this something like a particular, product or things like that? Or is this something available to everyone? How's that going to work on?
So the question has to do with IP, intellectual property, and patenting, and ownership, and all that. Interestingly, he found this gene in an old inbred. And I know he hasn't patented the gene, probably because it was already there. He didn't develop the gene. And he can't patent the inbred because it's an old inbred that's actually developed in Minnesota probably 40 years ago. So there won't be any intellectual property ownership on this particular patent, on this particular development. There won't be any on the Canadian immunophytic incompatibility or the pollen exclusion. And I mentioned that I'm developing open pollinator varieties. We're also developing ultra high quality hybrids, which I hope we can, which I'm hoping that we can move into the organic market. But I wanted to mention with the open pollinator varieties, the purpose of those, and there's not a lot of farmers, especially in the Midwest, that want to do this. The purpose of those is anyone, once you get that seed, you can save the seed, you can breed for adaptation to your farm, you can create your own variety. So actually, all the stuff I talked about today, there is no intellectual property.